Hello, hello, hello. Okay, guys. Don't know why screen is blue. I don't know why screen is blue. Okay. Yeah. So let's now see non-deterministic pushdown automata. Okay. Let's now see. Let me do it in a different one. Okay. All of you, please join the Telegram channel. Okay. All of you, please join the Telegram channel. I'm just coming in 1 minute. Okay. All of you, please join the Telegram channel. Okay, let's now see non-deterministic pushdown automata. Okay, let's now see non-deterministic pushdown automata. Non-deterministic pushdown automata. Okay, so you try for this. You try for this w power r w power r such that w belong to a plus b plus w belong to a plus b plus. So this is even length palindrome. This is even length palindrome. Okay. So can you try it? See, earlier we have seen odd length palindrome where center was known, right? Now this is even length palindrome where center is not known. Okay. Try this, everyone. You give it a try. I will explain. Okay. All of you come to Telegram channel. You try it. I will explain. Okay. ఉదయ ఎక్కడున్నావు? Try it, guys. Try it. No one is able to do. See, especially push-down automata and context-free grammars, you should try. See, if I have to give the answer, I will just finish off the entire course in 10 hours. And that is good for me. I'm giving you time to solve. I want you to learn on your own. And you are not doing it. What is this? How are you going to get ranks within 100? You have to do, no. Am I wrong? You have to try at least. No one is even trying. Wow, very good. Who is this? Pratibhanu. Hmm. Ah, very good, Pratibhanu. Excellent. Yeah. Only one person has answered it. What about others? Try it, please. At least try it. I'm not going to scold you if you do wrong. No. I just want to see some answer from you. Am I going to scold? No. This is the first time you are doing. Then why are you taking so much time? Try at least. See, you may not be right, but I will correct you. You may not be right, but I will correct you. Okay? Try it. Okay. So I'll explain you, then you try it. Okay? So what is the problem with even length palindromes is we don't know where the center is. Right? The problem is you will not be able to count the number of elements using a push down automata, right? And then you cannot divide. See, what will push down automata do? It will not give you the count and you have to divide it. Half of it will be W, half of it will be WR, right? So how are we going to do this? Let me take this example. A, B, A, A, B, A, right? So this is W and this is W power R. This is W and this is W power R. Okay, okay, fine, fine. Now, The thing is, we have to push till here, and from there we have to start popping. But the problem is, we don't know how much to push and how much to pop. So you have to do two cases simultaneously. One path will be pushing, one path will be popping. So see, see, there is one thing for sure. This is the center, right? Now, whenever there is a center, the symbol before it and after it will be same. That is the only thing we know. This cannot be the center because symbol here is A and symbol here is B. This cannot be the center because symbol here is A, symbol here is B. This cannot be center, right? So in this example, we are able to clearly find out the center, right? Because here there is A, here there is A, that could be the center. Now what if I give you a string like this, A. Now the problem is, this could be a center, we don't know. 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 But one thing is for sure, if there is a center, the symbol before it and after it will be same. Now that here there is a chance of getting a center, one path should start popping because center has come, and other path should start pushing because center has not come. So we are going to make two assumptions. Center has come and center has not come. Now I have explained you. At least now you should be able to do this, right? Aishwari Vardhan, very good Aishwari. Very good Aishwari. Very good Aishwari. Eight, yeah. 9 o'clock class ఉంది, 9 PM to 10 PM, గంటే 10 వరకే తీసుకుంటాం. Okay, so now let's try to do this. Okay, so this is a non-deterministic push-down automata. So initially A or B, if there is only one symbol, that is definitely not a center. Initially you may get A, Z0 is on top of the stack, push A. Or there may be B, Z0 is on top of the stack, push B. Okay. Fine. Now, if A is in the input and if top of the stack is B, there is definitely no center. Push A. If A is in the, if let us say B, if B is in the input and if A is on the top of the stack, push BA, push BA, right? So these two cases, see, these two cases are initial. These two cases are initial cases, right? And these two cases are the cases where definitely center has not come. Okay, so definitely center has not come, right? Now there are other cases. What are the other cases? I may see a in the input and top of the stack can be A. Then I am going to push A. If I see a B in the input, top of the stack is B. Now I am going to push B. Now what is the assumption for this? Might not be center, right? Even though there is a chance that it is a center, we are taking the assumption that might not be center, might not be center, might not be center. Okay, might not be center. Now, if I get a in the input and if A is on top of the stack, I'm going to pop off assuming that center has come. And if I see a B and B is in the top of the stack, I'm going to. So what are these two cases? These two cases are center might have come. Center might have come. Now once the center has come, you are going to pop only. A, on seeing A, you are going to pop. B, on seeing B, you are going to pop, right? And finally, what should happen? The entire string should be over and Z0 should be on top of the stack. Leave it as Z0 and accept it, right? Now, why is it called a non-deterministic pushdown automata is, look at this. So, this state A, okay, state B, state C. On state A, we have the configuration A comma A and we have the configuration A comma A. And here we are doing pushing, here we are doing popping, which means same configuration is doing two different things. And here also we have a same configuration, right? Now you know how NFA worked. Whenever there were two states that NFA has to go, it made copies of itself, right? And at least if one of the copies reaches the final state, at least Okay, I'll take an example and explain you. Okay, I'll take an example and explain you. So let us take an example. Let us take an example. A, right? Right. So just remember this diagram. Just remember, otherwise I will do it here only. Okay. Okay, I will tell you how to do this. Okay. Very simple. If you can do this, you can do any question. This is the only difficult question in non-deterministic push-down automata, and many of you are able to do this. So I think you are doing great. Okay. So don't worry, you will get a good rank. Only thing is, see, you have to try. See, my problem with the push-down automata is I can't directly give you the answer. If I give you the answer, your thinking ability will reduce. You have to think and form more connections in your brain. All the neural connections have to be set. Then you will be able to answer new questions once the patterns are set, right? That is why I'm giving you time to practice, but you are not doing it. So, yeah, some of you are doing it. Okay. So see guys, now let us say we are in state A and we are seeing A, and top of the stack is Z naught. Top of the stack is Z naught, right? Now what will A do when it sees the first string A and Z naught on top of the stack? It will just push. So it will not do anything. It will be in state A only, and it will push this A onto the stack. Therefore, 3 A's are remaining, and it will push A onto the top of the stack. It will push A onto the top of the stack. Right, right. Now see this. Now see this. A is in the input and top of the stack is input. So we have two cases. Maybe there is a final state, may not be a final state. So our push down automata will make two copies of itself. Our push down automata will make two copies of itself. One copy will assume that center has not come, then it will stay in A only. Center has not come, it will stay in A, and it will push this A onto the stack, which means you are going to get A, Z naught. Now what will other copy assume? That the center has come and it will pop off this A, right? So it will go to B, it will go to state B, right? It will go to state B, it will go to state B, okay, and pop off this symbol. It will go to state B and pop off the symbol. Then A will be remaining and Z naught, right? Now if you look at it, B, if it sees a and Z naught, it is not defined, right? For B, A and Z naught is not defined. So this will die. This copy will die. We are not going to follow this path. This copy will die. Okay. This copy will die. Okay. Now what happens to this? See this. Input is A and top of the stack is A. So there are two cases. One case will assume center has not come. What will happen? It will be in A only, center has not come. So it will do pushing. So A comma A, Z naught, Z naught, right? Now center has come. If the center has come, it is going to go into the state B and it is going to pop off the A on the top of the stack, and this A will anyway be gone because it is the input. Then we get A Z naught. Okay. Now again here there are two cases. A is in the input and A is on the top of the stack. A is in the input and A is on the top of the stack. A is in the input and A is on the top of the stack. Right? So there are two cases possible. See, let me write the cases also so that you will understand. So this is the initial condition. This is assuming that center has not come. This is assuming that center has come. This is assuming that center has not come. This is assuming that center has come. Now again here you will get two cases, right? Because input is A and top of the stack is A. One, we assume that center has not come. Center has not come. If the center has not come, then input will be over. We are going to push A, Z naught. Now if you observe A epsilon A. So on A, there is no transition defined on epsilon. Therefore, this copy will die. Center has not come, copy will die. Now here, center has come. Okay, which means here center has come. Right, right. Here, center has come. Assuming that center has come, popping will happen. Input will be over and this A will be popped off. A Z naught. Again, for capital A, epsilon is not defined. Now, once you have reached B, there is only one chance. Center has come, right? So, you are going to do B, input will be over and popping will happen. B epsilon Z naught. And capital B on epsilon Z naught is going to capital C. So, we have accepted, right? Now, if you observe it, every time our NPDA is making copies of itself. Every time our NPDA is making copies of itself. It is non-deterministic because it is not exactly saying go to this state. It is saying go to this state or follow this path or follow this path. Follow this path or follow this path. Okay. Okay. This is about NPDA. I'll give you one more example. There are only few examples about this, but they are sufficient. You will be able to handle any case. Okay. Now let us say language L equal to A power n, B power n such that n is greater than or equal to 1 union A power n, B power 2n such that n is greater than or equal to 1. Do for this. Try it. Do for this. Try it.
ప్రస్తావనలు.
Okay, so what is this? So what is this? Listen, A's can be equal to B's or B's can be double the number of A's. Now the problem is when I see the first A, I don't know whether A's will be equal to B's or A's will be double that of B's. When I see the first A, when I see the first A, I don't know whether both are equal or not equal. So we have to take two paths. One path should check if A's are equal to B's. Other path should check if A's are double the number of B's. If A's are double the number of B's. If A's are double the number of B's. Okay, so what can we do? Okay, now I have explained you, right? Now you try it. You have to try. Hmm. No one has answered it right. Try. Okay. I feel that this is easy question only, but somehow this guy has done it right. Kirutika and Pratibano. Yeah, you are right. Okay. So whenever you see A, right, you take two paths. Whenever I see A and Z0 is on top of the stack, I take two paths. Same configuration, I'm going to two paths, right? One path will just push one A and other part will push two A's. Other part will push two A's, right? Now the path which has pushed 1A will keep pushing. See, this path is for A power n, B power n, okay? And this path is for A power n, B power 2n. One path is for a power n, b power n, and the other path is for a power n, b power 2n. A power n, b power 2n. Right, right. Now you do it. At least now you should be able to do it. At least now you should be able to finish it. Try doing it. At least now you should be able to do it. Try doing this. Very good. Now people are able to do this. Yusuf, very good. Very good, Yusuf. Okay. So here, any number of A's may come. Just keep pushing A's. Once a B comes, pop the A. Any number of B's comes, pop the A. Right? And finally, if A's and B's are equal, you will get epsilon. You will get epsilon. You will get epsilon z naught on top of the stack. Leave it as z naught and accept it. Now, what is the other path? For every A, we are going to push 2 A's. Now, once I start getting B's, for every B, if A is on top of the stack, I am popping it. For every B, if A is on top of the stack, if for every B, if A is on top of the stack, I'm going to pop it. Finally, if I see epsilon, if everything is over, z naught on top of the stack, I am going to leave it as z naught and accept it. Right? So why is this called an NPDA? See, the NPDA comes from the fact that a state A on seeing the same configuration is doing different things and it is going to different states. Because of this fact, this is called NPDA. This is called NPDA, right? Good. So now we have solved a lot of questions. Now we have solved a lot of questions. Okay. Okay. So now you will be, see, in exam, they are not going to ask you to draw the push down automata. When I show you the PYQs, I will show you that. Okay. So in exam, they are not going to ask you to draw the push down automata. Then what questions are possible? Given a language, is it regular? Is it DCFL? Is it CFL? Okay, that's only. So we'll solve those models now. Now I will not draw push down automata anymore. We are done. We are done. We have done enough number of questions. Okay. Yeah. So here you can merge these two. You don't have to have two separate final states. Even if you have two separate final states, that's not a problem. You can merge here. As I told you, there is nothing called minimization of push down automata. There is nothing called minimization of push down automata. Okay. Tell me about this. I'll give you languages. You have to tell me whether they are regular or not, DCFL or not, everything. Okay. A power m plus n, b power n, c power m, such that n comma m greater than or equal to 1. Tell me whether it is regular, DCFL or CFL. Regular or DCFL or CFL. Everyone is saying that it is DCFL. Everyone is saying that it is DCFL. Right? Very good. So this is DCFL only, right? See, whenever such a language is given, you write about it. A power m, b power n, c power n, c power m. This is definitely not regular because comparison is involved. So this is definitely not regular, right? And we exactly know when to push and when to pop. How are you going to solve this? Push all A's, push all B's, pop B's, pop A's. So when to push and when to pop is exactly clear. Therefore, this is DCFL. If it is DCFL, it is CFL. If it is CFL, it is recursive. If it is recursive, it is recursively enumerable. Okay. Now answer next question. A power m, b power m plus n, c power n such that m comma n greater than or equal to 1. Such that m comma n greater than or equal to 1. What language is this? Very good. This is definitely not regular, but we know when to push and when to pop. So this is DCFL, right? Right. Hmm. A power m, b power n, c power m plus n such that m comma n greater than or equal to 1. M comma n greater than or equal to 1. Try this. Try this. Very good. This is DCFL, right? This is DCFL. Answer the next question. A power m, b power m, c power n, d power n such that m comma n greater than or equal to 1. Very good. We know when to push and when to pop. Push A, pop A. Push C, pop C. So this is DCFL, right? And it is definitely not regular, but it is DCFL. Now answer this question. A power m, b power n, c power m, d power n such that m comma n greater than or equal to 1. See, these two have to be compared. These two have to be compared. Now the problem is I have to push A's, okay? And then I have to push B's, okay? Now when the C's come, I have to compare with A's. But on top of this tag, B's are there. So this language is definitely not regular. This language is definitely not DCFL. This language is definitely not CFL. And this language is CSL. We will see CSL later, okay? A power m, B power n, C power n, D power m such that m comma n greater than or equal to 1. Very good. Push A, push B, pop B, pop A. We know when to push and when to pop. So this language is not regular, but this language is DCFL. A power m, A power I, A power m, A power I, A power I, B power m such that n comma m greater than or equal to I is also there, right? M comma I greater than or equal to 1. Solve this. Try this, everyone. Can someone tell me the answer why it is CFL or why it is DCFL? Anything? Okay. Okay, see this. This one I can write it as a power m plus I b power m. Okay, this one I can write it as a power n b power m such that n is greater than m. And this is DCFL, isn't it? M plus I is greater than m. So I can write it like this. And this is DCFL. And this is definitely not regular. Okay. Answer this question. A power n, a power j, b power n, c power k such that n comma j comma k greater than or equal to 1. N comma j comma k greater than or equal to 1. Okay. So how you would write it? A power n plus j, b power n, c power k such that this is the case. Now I can write it as a power m, b power j n, c power k such that m is greater than n. M is greater than n. Now there is no condition on c. You just check this and then you just check c's. See if you try. Can you draw the DFA for this? Sorry, PDA for this? Just for fun. It is not required. They will not ask you in the exam. Can you draw the DCFL for this? Can you draw the DCFL for this? Very good. Kirutika is rocking. Okay, so guys, how to do this? How to do this? So A's have to be greater than B's, right? So initially A will definitely A will come. Here the condition is all of them are greater than or equal to 1. A will come, Z naught, push A. Okay. And then any number of A's may come, push A. Fine. And then B will come. Whenever B comes, if A is on stack, push epsilon. Similarly, any number of B's will come, A is on top of the stack, pop A. Now what should happen? A should be greater. So by the time C comes, if top of the stack is A, leave it as A as it is and see that there are only C's, right? C is coming and A is on top of the stack, leave it as A. Okay. Now you have to see all the C's are over. Then finally epsilon will come, A will be on top of the stack, leave it as A and you accept it. So extra number of A's can be done like this, right? Right? And we have done this question also. A power m, B power n such that m is less than n. A power m, B power n such that m is less than n. This to we done. This is DCFL. Just now also we have done, right? Right? Then A power n, B power 2n such that n is greater than or equal to 1. This to we have done, DCFL. Now A power n, B power n square such that n is greater than or equal to 1. N square. Try this. Try solving this. Tell me if it is DCFL, why it is DCFL. So we know that nonlinear powers cannot be done by finite automata. and push down automata is finite automata plus stack, right? So this is not regular, this is not DCFL, this is not CFL, but this is CSL. We'll see CSLs later, okay? Tell me about this. WWR such that W belong to A comma B star. WWR such that W belongs to A comma B star. Okay. So this is what, guys, even length palindrome. Even length palindromes. And we know that this is not regular and this is not DCFL. This is CFL. This is CFL, right? Now we have seen also this WCWR. When the center is known, W belong to A comma B star. When the center is known, this is not regular, but this is DCFL. This we know, okay? This we know. Okay, this we know. Now, what about WW such that W belong to A comma B star? See, WW is a different class of problem. So let us say W equal to ABB, right? Then WW is going to be ABB, ABB. Now the problem is, if I have a stack, I will push ABB onto the stack. Now I have to compare A with A, which means I have to compare with bottom of the stack, which is not possible. Therefore, this is not regular. This is not deterministic context-free language. This is not CFL also, but this is CSL. We will see that later. Okay. Okay. Now, A power n, B power n, C power m such that n is greater than m. Now in this problem, A's and B's have to be compared and also B's and C's have to be compared. See, once I compare B's with A's, stack will be empty, right? Once I compare B's with A's, stack will be empty, B's will be over. You cannot compare the C's. Therefore, this is not context-free language. not regular, not DCFL, not context free language, right? So we in CFL we can do only in CFL in CFL we can do only one comparison at a time. Two comparisons are not possible. A power n, B power n, C power n, D power n, such that n is less than or equal to 10 power 10 power 10 power 10. Answer this. Okay. Very good. So this is a finite language. See, this can be any big number, but still it is finite language and therefore it is regular. Now tell me about this a power n, b power 2n, c power 3n such that n is greater than or equal to 1. N is greater than or equal to 1. So you can compare a power n, b power 2n, but by that time a's are over, b's are over, there will be nothing left to compare with c. So this is not CFL, this is definitely CSL. Okay. Answer this question. A power n, B power 2n, C power m such that n comma m greater than or equal to 1. M comma n greater than or equal to 1. Okay, very good. This is DCFL, right? A's and B's can be compared and then C's can be any number. See, how are you going to draw the push down automata when there is a and Z0 on top of the stack? You push two A's, okay? And when there is A and A is on top of the stack, you push two A's, okay? Now, when there is a B and A is on top of the stack, you pop A and you keep popping A. When there is a B and A is on top of the stack, keep popping A. Finally, A's will be over and B's will be 2n. Okay, then we will see a C. Z0 will be on top of the stack. You don't do anything with C, just leave Z0. Now you see that all the C's are over. C, Z0, Z0. Finally, you are going to get epsilon. Finally, you are going to get epsilon. So finally, when you see epsilon, Z0 is on top of the stack, C's are over, then you accept it. Okay. Now answer this question. Answer this question. A power n, B power 3m, C power 2n such that n comma m greater than or equal to 1. Okay. What is this language? So Pratibhanu is saying DCFL. Aishwari is saying DCFL. Shiva DCFL. Okay. Kirutika DCFL. Yeah. So this is DCFL, right? So A's and C's have to be compared and B's have to be multiple of 3. So what are you going to do? First, whenever you get C, A's have to be, C's have to be double that of A's. So whenever you see a and top of the stack is Z0, you push 2 A's. Whenever you see a top of the stack is A, you push 2 A's. You push 2 A's, right? Now once you start getting B, top of the stack is going to be A, leave it as A, and then see that number of B's are multiples of 3. Okay. So 1B, 2B, leave it as B itself, and then 1, 2, 3, B, A, leave it as A. Okay. And now you put a loop here. I think something is wrong here. B, A, 1B, 2B, 3B, right? So this has to go here. 1B, 2B, 3B, right? Right. Okay, this has to be kept here. And then anyway you can do number of B's equal to 2. You can do that. We have seen that. Okay. Now let us say x is there where x belong to a comma b star, where x belong to a comma b star. It is same as WW with a center, right? It is same as so this is same as WW, right? So this is CSL. Okay. This is not CFL. Okay. Now XCY such that X belongs to 0 comma 1 star, X comma Y belong to 0 comma 1 star, XCY such that X comma Y belong to 0 comma 1 star. Try this. So this is what 0 plus 1 star C 0 plus 1 star. Set of all strings containing C. So this is regular. This is regular, right? X power R such that let us write W only. W power R such that W belong to A comma B star and mod W equal to 100. Mod W equal to 100. Okay. Okay. So this is finite, right? Mod W equal 100 means finite. Finite means regular, right? Then W power R such that W belong to A comma B star. CFL cannot do W. So this is not CFL, not regular also, but this is CSL. Okay. Okay. Now A power n, B power 3 power n such that n is greater than or equal to 1. This is a non-linear power. Finite automata cannot do non-linear power and push-down automata is finite automata plus stack. So this is CSL. Okay. Now A power m, A power m, B power n such that m is not equal to n. Can you draw the so this is DCFL. Can you draw the DPDA? Draw the DPDA for this question. Okay, so A's can be greater or B's can be greater, right? Okay, so this is a little bit tricky. This is a little bit tricky, okay? So people think that this is NPDA. Okay, try it. People generally think that this is NPDA. Mm. Okay, fine, let me do this. See, initially when there are A's, you are going to push A's. Okay, any number of A's, you are going to push A's. A, A. Fine. Now, whenever you get a B, you are going to pop A, right? Now, as long as you get B's, you are going to pop yes. Now there will be two conditions, right? Maybe b's may be greater, which means b's will be there, and then you are going to see z naught. Okay, leave it as z naught and completely see the b's. Completely see the b's. Okay. Finally, when the b's are over, z naught is on top of the stack. Leave it as z naught and you accept it. And one other case is yes may be greater, which means string will be over. Still we will have yes on the stack. Leave it as a and accept it. Right? So this is a deterministic pushdown automata. There is no non-determinism here. Okay. Okay. Fine. Now similarly you can do any such model. A power I, B power j such that I is not equal to 2j plus 1. This is also DCFL. Okay, not regular DCFL. Now A power m, B power n such that m equal to 2n plus 1. M equal to 2n plus 1. How are you going to solve it? In place of m, you are going to put 2n plus 1. This one you are going to write 2n a b. 2n a b. This is DCFL. Right? You can do the pushdown automata for it. It is not so easy, but you can try it. Okay. Now anyway you know all this. A power n square, a power n factorial, a power 3 power n, a power p such that p is prime. All this we can do. Right? So all these are not regular. Even pushdown automata cannot do anything. So these are not context free languages. These are context sensitive languages. Okay. Okay. Answer is a power k such that k is even. Even number of a's is regular, right? And answer is a power I, b power j, c power k such that I is greater than j is greater than k. I is greater than j is greater than k. So we need three comparisons. I, J, K have to be compared. This cannot be done by CFL. Now answer this question. A power I, B power J, C power K such that J equal to I plus K. This we have already solved it. A power I, B power I plus K, C power K. So what is this? A power I, B power I, B power K, C power K. Right? Right? Push, pop, push, pop. So this is DCFL. Okay. Okay. Now A power I, B power J, C power K, D power L such that I equal to K or J equal to L. I equal to K or J equal to L. Okay. So this is a non-deterministic non-deterministic context-free language. The reason is you are going to have two paths, one path, one path. In one path, you will check I equal to K, and other path you check J equal to L. If any of these paths reach the final state, you are going to accept it, right? So you are going to get NPDA, right? So this language is not regular and this language is not DCFL. It is not regular and it is not DCFL, okay? Okay. Answer this question. A power I, B power J, C power K, D power L, such that I equal to K and J equal to L. I equal to K and J equal to L. Okay, so here I has to be compared with K and J has to be compared with L, and both of them have to be compared simultaneously. But push down automata can only do one comparison at a time. Therefore, this is not CFL. This comes under CSL. Okay. Answer this question. A power M, B power L, C power K, D power N, such that M, L, K, N greater than or equal to 1. M, L, K, N greater than or equal to 1. Right. So what is this language, guys? There is no relation among them. A plus, B plus, C plus, D plus. So this is regular. This is regular. Right. Now A power N, B power 4M such that N comma L greater than or equal to 1. What is this? A star B B B B star, but then greater than or equal to 1 is given, right? Put A B B B B, right? So this is the regular expression. So this is regular language. Okay. Tell me about this. A power 3, A power 8, A power 13, A power 18, so on. Right? You can write, this is GP with a single element, right? Right. So the difference is 5. How are you going to write the regular expression? The regular expression is going to be starting symbol is A, and then you are going to get all the remaining symbols by putting a star here. So this is the regular expression, and therefore the language is regular. And this one, A power 2n plus 1 such that n is greater than or equal to 1. This is odd number of A's, regular. A power n power n such that n is greater than or equal to 1. This is non-linear power. Therefore, this is not regular. This is not DCFL. This is not CFL, but this is CSL. Right? Right? W such that W belong to A comma B star, and number of A's in W is equal to number of B's in W. We just did this. This is DCFL. This is not regular. This is DCFL. Right? Now W such that W belong to A, B, C star. Number of A's in W is equal to number of B's in W is equal to number of C's in W. A's, B's and C's should be equal. So A's have to be compared with B's, B's have to be compared with C's. Unfortunately, CFL can do only one comparison at a time. It cannot do two comparisons at a time. Therefore, this is not CFL, this is CSL. In fact, we will derive a grammar for this in CSL. I'll explain you at CSL, okay? W such that W belong to A comma B comma C star, and number of A's in W is equal to number of B's in W, or number of B's in W is equal to number of C's in W, right? So we have to either compare A's with B's or B's with C's, not both of them at a time. So one comparison at a time can be done by CFL. One comparison at a time can be done by CFL, right? So you are going to have two paths. One path is going to compare A equal to B, other path is going to compare B equal to C, right? So this is non-deterministic context-free language. This is not DCFL. This is not DCFL, right? Right? So W such that W belong to A comma B star. Number of A's in W is equal to number of B's in W plus 1, which means one extra B you should get. One extra B you should get, right? So what do you get here? String may be over, and on top of this tag there may be one extra B. Let us put greater than or equal to, okay? String may be over, top of this tag there may be B's. See that there are only B's. Or B may be in the top of this tag, we get Z naught. You can draw it, okay? We have seen a lot of examples, we can draw it, okay? Now we are done with push down automata. Now let's look at the definition of push down automata, okay? Okay. So let's now see the push down automata definition. Okay. Push down automata definition. Push down automata is going to have Q sigma delta Q naught Z naught final states and tau. This is tau. This is called as tau. Okay. So Q is finite set of states. Q is finite set of states, and sigma is input symbols. Sigma is input symbols, and delta is transition function, and delta is transition function, and Q naught is initial state. Q naught is initial state, and F is set of final states. F is set of final states, and tau is stack alphabet. Tau is stack alphabet. What are the symbols allowed in stack alphabet? Now we know that push down automata is of two types. See, you know what is Q? Set of states. Sigma is input symbols. Delta is transition function. Q naught is initial state. F is set of final state, and tau is stack alphabet. NPDA is of two types. One is deterministic, and the other one is non-deterministic. One is deterministic and the other one is non-deterministic, right? So in this deterministic, Q cross, what are the symbols that it can see? One is sigma, and also it can see epsilon, and then it will see top of the stack. Understand this. If you are in a state, you will see some input symbol, or you will see epsilon, and you will see the top of the stack, and then go to one state, only one state, but then you can push any number of symbols on the stack. Now what about non-deterministic push down automata? Delta is Q cross sigma union epsilon cross tau, which means one state will see one input or epsilon and see top of the stack, and then it can go to any number of states and it can push anything onto the stack, just like DFA and NFA, and NFA, right? Okay, with this we have completed push down automata. Okay, with this we have completed push down automata. Now we have to see context free grammar. Okay, we have to see pumping lemma, and then we will see context free grammars. Okay, so we'll end the class here. We'll end the class here. I will be doing AI Generalist ka video today. Okay, so we'll end the class here. Okay.